We learned to simplify radicals yesterday, and that was to prepare us for today's lesson. So we learned to find the roots by looking at a graph and by looking at a table on the calculator to find the roots are the x-intercepts. It's where y is 0. But sometimes they don't show up in the calculator or on the graph at an exact point. Sometimes they're at a fraction or a decimal. So we had to learn other ways. So we learned factoring. We learned to find them by factoring. Today's method is we're going to learn to find them by taking the square root. So this method you use when the x term is missing. So we talked about how the standard form of a quadratic is ax squared plus bx plus c equals 0. So when you don't have that bx term, when you don't have the x, when it's missing and all you have is a squared and a constant, that's when you want to use this method, when the x term is missing. So first you isolate the squared term on one side of the equal sign. When we solved by factoring, it was very important to set it equal to 0. This is the only method you don't do that on. On the square root, we don't set it equal to 0. We want the squared term by itself isolated on one side of the equal sign. And yesterday I told you that there was both a positive and a negative square root of each number. Well, today we're going to use that. Remember how we usually have 2 roots? The way we get our 2 roots, our 2 answers, is by doing both the positive and the negative square root. And then we're going to solve for both, if there are both. Sometimes you just have one root, remember? And sometimes we have no roots. So let's look at some examples. We'll start off with an easy one. Now you could do this one in your head. If x squared is 9, what number times itself is 9? Well, it should be 3 or negative 3. But let's see how we would solve it algebraically. The way you would solve it algebraically is take the square root of x squared to get x. But what you do to one side of the equal sign, you must do to the other. We've worked on that ever since we've started solving equations. So if I take the square root of this side, I must also take the square root of this side. And I want both the positive and the negative square root. So I'm going to get positive or negative 3. I can write it like that. X is both positive and negative 3. Or, remember how I wrote my roots in brackets? I can do that. I can write it in brackets, negative 3, positive 3. So, number 2, let's do it the same way, except this is where we used yesterday's lesson of simplifying radicals because 8 is not a perfect square. So let's take the square root of each side. X equals the positive or negative square root of 8, but that's not a perfect square, so let's simplify it. What can we split 8 into? Can't we split it into 2 times 4? And what is the square root of 4? It's 2. So x is positive or negative 2 square roots of 2. Because, now, I wouldn't write this one like we did the first one in the brackets because you just have to rewrite all this again. I would just leave it like this. Positive or negative 2 square roots of 2. Because 8 simplifies to 2 times 4. Square root of 4 is 2. That 2 remains. Let's look at number 3. So if we take the square root of both sides, x is, what's the square root of 1? It's just 1. So x is positive or negative 1. Now we get to one that's not equal, that the x squared is not isolated. So far, x squared was by itself on one side of the equal sign. Here it is not. So the first things I do is isolate it. How do I get rid of a minus 400? I do the opposite, which is a plus 400. Now this x squared is isolated on this side of the equal sign. Now that it's isolated, I take the square root of both sides. X is positive or negative square root of, all right, 400. Oh my goodness, I almost messed up. 400 is a perfect square. What's the square root of 400? It's 20. So there's my answer, positive or negative 20. Don't do more work than you have to do. If you're not sure it's a perfect square, always check first. Put it in your calculator and see. So now I have this one that is not isolated. So to isolate the x squared, I add the 40 to both sides. That just moves it to the other side, making it positive. Square root of both sides. Now, what can I split 40 into? Well, I know 4 is a perfect square. How about 4 times 10? Nothing else is going to work for me because 10 doesn't have a perfect square in it. It's not going to simplify. So x is positive or negative 2 square roots of 10. Because square root of 4 is 2, and then the 10 can't be reduced. All right, get a little trickier here. These are going to, they're kind of intensifying in difficulty as we go along. First, I have to isolate the x squared. So I need to get rid of the minus 60 by adding 60. Now I need to get rid of the 3. Don't take the square root of this. You're going to have a mess. Let's get the squared by itself before we take the square root, or you will get into a huge mess that won't help you. So the first thing we do is get rid of the 3. We do that by dividing it. X squared equals 20. Take the square root of both sides. I was thinking we had already done that one, but we haven't. X equals positive or negative square root of, this one's going to be 4 times 5, and square root of 4 is 2. We can't reduce the 5. So there's our answer on that one. So you had to do 2 things first. It's just like solving for x. Pretend this was an x. You would add the 60, divide by the 3 to get x by itself. But instead, we're getting the x squared by itself. Same process as isolating the x. Then, only after we've isolated it do we take square root. Now this one, I have a whole parentheses that's squared. My squared term is isolated. This whole thing in parentheses is squared. So I can go ahead and take the square root of both sides because the whole parentheses is squared. I can't do something, I can't get something out of parentheses when there's this squared here because PEMDAS tells me that exponent has to be taken care of first. So it's kind of like we're doing PEMDAS backwards. Let's take the square root of both sides. All that does is get rid of the squared and leave me with what's in parentheses. So I just get rid of the squared. Now I have x minus 6. Drop the parentheses. What is the square root of 144? It's 12, but remember, I need both the positive and the negative 12. At this point, I'm going to make 2 equations. Remember how when I factored, I made 2 equations and solved them both? This is the same thing. I have that x minus 6 could equal 12, but I also know that x minus 6 could equal negative 12. This is how I take care of both the positive and the negative answers. I have to solve both equations. So for this one, I would add 6. And I would get it that x is 18. For this one, I would add 6, and I would get that x is negative 6. So what are my 2 roots? Negative 6 and positive 18. Let's do the same thing on number 8. The squared part is isolated. So I take the square root of both sides. All that does is drop the parentheses and the squared. What's the square root of 81? It's a positive or negative 9. So now I have 2 equations. I have that x plus 5 equals positive 9, or x plus 5 equals negative 9. So I minus the 5, and I get that x is 4 or negative 14. Those are my 2 roots. Remember, most of the time we're going to have 2 roots. Now, occasionally you're going to end up with only 1, and we'll do an example later of what that would look like. I'm not really going to give you one that would be none on a root problem like this. If you were trying to take a square root of a negative number, that would be when you'd have no roots, but we don't do that to you in Algebra 1. All right, this last one's going to take a few steps. So the squared part right here needs to be isolated, and it is not. Let's just kind of make a little mess here. The first thing we do is remember your order of operations and your solving equations or steps do not change. We're still doing the same process we've done all year long. So the first thing we do is get rid of that 18. Now what do you suppose we need to get rid of? The 3. Divide by it. Now this looks a lot nicer. Now that my parentheses squared is isolated, now I can take the square root of both sides. X minus 4 equals positive or negative 10 because the square root of 100 is 10. And I need both the positive and the negative answer in there. So I'm going to do two equations. X minus 4 is positive 10. X minus 4 is negative 10. When I add the 4, x is 14 or negative 6. So this is the method we use. Most of the problems don't have as many steps as that last one. This is the method we use when there's no x term. When the x term is missing and we can just take the square root of both sides, it's a lot faster and easier, in my opinion, than trying to factor it. Sometimes it won't factor, as you can see by these weird answers.